Today we're going to talk about Unit 5, Lesson 1. So we're looking at function operations. So the operations that we're used to are addition, subtraction, multiplication, and division. So we're going to use functions to do those things rather than integers or other numbers. Some of these questions will ask us about domain. So we want to remember that domain is all the possible x values that actually give a solution. And what I mean by a solution is that we can't have undefined or does not exist. And so I should get an answer. In general, these are going to end up being when I'm dividing two functions together, and it's those restrictions of the denominator, or if I have a square root, a number that would make that square root negative. So we'll talk about that when we get to the problems that are more akin to this. And so notice that there's two different sides to each equation when I'm talking about addition. So it's, you have f plus g in parentheses and then x in parentheses. That is exactly the same as f of x plus g of x. So it's f plus g of x. It doesn't mean that I'm multiplying things times x. It means that I'm literally taking f of x and adding it with g of x. And so within my equation, f of x is negative 2x plus 6. So I'm going to replace that with that expression. So negative 2x plus 6. And I'm going to add that to g of x, which is 5x minus 7. So 5x minus 7. When I'm adding, the second expression isn't changing at all, so I can really ignore my parentheses. So I have negative 2x plus 6 plus 5x minus 7, and I can go ahead and combine like terms. So my like terms here are negative 2x and 5x. If I add those together, I get 3x. And then I have constants, so 6 plus negative 7 is going to give us negative 1. So our f of x plus g of x is 3x minus 7. The type of function is ultimately going to dictate our domain. So if I look at this function, it's a polynomial, meaning there's no roots or dividing by variables, things like that. That has a degree of 1, which means that this is a linear function. And a linear function does not have any restrictions. And so that means that our domain for this one is all real numbers. So I'm going to write out the symbol for all real numbers. Remember that you could, if you prefer, write it as an interval of negative infinity to positive infinity. If that's your preference. So I'm going to consistently write the symbol for all real numbers rather than that infinity. So when we do the next problem, f minus g of x, that's telling us that we want to take f of x and subtract g of x from it. So that means that we're going to take our negative 2x plus 6 and subtract our 5x minus 7. What happens when we subtract is the symbol, or sorry, the signs on G change. So negative 2x plus 6 is going to stay the same, but I'm going to change the signs here. So I have a minus 5x and then plus 7. So now when I combine like terms, my x terms, I have negative 2x plus negative 5x. So that's going to give us negative 7x. And then we have positive 6 and positive 7. So our constant term is going to be positive 13. So notice that this is still a linear function. So I still have it as a degree of 1. Which means that my domain is the same, because the domain is the same for all linear functions. And so our domain here is all real numbers. For C, it looks a little different, and it ultimately kind of looks like a just an expression that we would plug into, and that's really what's happening. So our g of x is being multiplied by 2, and then our f of x is being subtracted. So we're really just taking those two functions and plugging them into this expression. So we have 2 times our g of x minus our f of x. So we're going to replace that whole function with our g, which was 5x minus 7, and with our f, which was negative 2x plus 6. I don't know what I just wrote, negative 2x plus 6. Okay, so we're replacing g in there and f in there because it's telling us to do 2 times g minus f. And so now we have to simplify both of these. So if we simplify the 2 times g, we're going to multiply 2 times 5x, so 10x, and then 2 times negative 7, which is negative 14. Then we have to distribute the negative signs. So we're really just changing our signs from positive to negative or vice versa. So negative 2x is going to be positive 2x, and then minus a 6. So now we're ready to combine our like terms. We still only have x's and constants. So if we combine our x's, 10x plus 2x is 12x. And then negative 14 plus negative 6 is negative 20. So our resulting expression is 12x minus 20. And again, this is still linear. So when I'm adding and subtracting two linear functions, notice that I still get a linear function as my answer. So a linear function has a domain of all real numbers. So those are my two answers. So notice that when I'm adding or subtracting, I might have to change the signs on an expression when I'm subtracting. Sometimes they'll give me more things where I have to multiply by a number. In the next side, we're going to actually multiply entire functions together. So this is similar to what we saw when we were looking at just the section on polynomials. So it's asking us to complete each operation and state the domains of our results. So f times g of x written like this, remember, is equivalent to f of x times g of x. So I'm going to take f of x, which in this case is x squared plus 1, and I'm going to multiply it times g of x, which in this case is x to the 4th minus 1. So I'm taking f of x and multiplying it times our g of x. So what's happening here is I'm multiplying two binomials together. So I either have to do the double distribution, aka FOIL, first, outer, inner, last, or I can draw a 2 by 2 box and use that to multiply it out. So whatever your preferred method is, I'm just going to use double distribution. That's how we're going to get to this next step. So I'm going to multiply x squared times x to the 4th, and that's going to give us x to the 6th. So remember, we're adding our exponents, not multiplying them together when we do this. Then x squared times negative 1 is going to give us negative x squared. Next, we're going to multiply 1 times x to the 4th, so plus x to the 4th. And then last, we're going to multiply 1 times negative 1, which also gives us negative 1. And so our next step would be to combine like terms, but what we should notice is that we don't actually have any like terms. So let's just write this polynomial in standard form. So we have x to the 6th comes first, then we have an x to the 4th minus x squared minus 1. So since we can't combine anything, we're just reordering it so that all the powers line up in decreasing order. And then we're going to evaluate our domain. So this is a polynomial right? We've got a degree of 6. So this is a 6th degree polynomial. For any polynomial, it still has the same domain as a linear function, because a linear function is just a 1st degree polynomial. And so that means that our domain here is still all real numbers. Okay, so there are no restrictions on a domain if it's a general polynomial. So remember that in terms of linear functions, these are just 1st degree polynomials. So they are still following under the polynomial rule for domains. So domains have no restrictions for polynomials. I can't plug something in and somehow get an undefined value. For the last problem, this is really where domain is going to change. So when we're looking at this, what we're doing is we're dividing. So f over g of x means I want to evaluate f of x divided by g of x. So if I'm looking at this, I want to take f of x, which is x squared plus 1, and I want to place it over g of x, which is x to the 4th minus 1. And so what's going to kind of change here is that in order to do anything with this, we have to think back to what we just talked about in Unit 4, which is factoring and being able to reduce out like factors. And so we want to, when we're doing division, we have to factor anything that we can factor and then divide out like factors. Okay, so x squared plus 1 is not something that I can factor because it means that I want to find something that multiplies to 1 and adds to 0. So the only options for multiplying to 1 would be +1, +1, or -1, -1. And none of those will add to 0. They either add to 2 or -2. So that means my numerator has to stay x squared plus 1 because that's a prime polynomial. For the denominator, however, I can think about it as a product sum as well. So I did magic x there, so I'll write out product sum for this one. So my this is going to be one where, since it's x to the 4th power, our 2 factors are going to be x squareds instead of x's. So if we recall this from when we did polynomials in Unit 2. But this time we want something that multiplies to -1 and adds to 0. And so +1 and negative work because, I wrote a 2, because they multiply to -1 and then they add to 0. So what we want to be able to do now is we want to simplify. So we want to simplify these factors, meaning if there's anything that is the same, I can divide out to 1. So this turns into 1 and this turns into 1 if I divide by them. And so I'm left with a 1 on top and an x squared minus 1 on the bottom. So what we want to check now is, can we factor this any further? Because a factorization will help us see what our restrictions are and what our domain is. So we should notice that this is a difference of 2 squares. So we should be able to see that, okay, so x squared minus 1 factors to x plus 1 times x minus 1, because it has the same product sum that we just did with the x to the 4th minus 1. So notice that the only difference is, instead of x squareds, we have x's. And so this doesn't necessarily help us in terms of like being able to simplify or get our answer. So really either one of these would be appropriate answers. However, the second one helps us find our domain, okay? So remember that with rational functions, we have restrictions. So our restrictions are any value of x where it would make our denominator 0. So remember that what number would make x plus 1, 0 is -1. And then the number that would make x minus 1, 0 is +1. And so these are our restrictions on the variable, which means that our domain can be expressed as all real numbers except x being 1 or -1. Okay, so when it's rationals, we have these restrictions, and that tells us what's excluded from our domain. So typically we would have all real numbers. Because these values, 1 or -1, would give us 1/0, which is what's undefined, we have to exclude them from our domain. So really the only time you're going to have different values on your domain are when you're dividing, or if you're given a rational expression to start with. So for this assignment, you should be working on page 406, doing 1 through 19 odd, and then 45 to 55 odd. So as you're working on this in your notebooks, you could always go back, if you finish this, and go back to, we worked on lesson 2 yesterday out of order, and look at those function composition problems and maybe get some more practice with those.